Welcome to Linear Equations Level 3. Pause the video now, try the 4 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're solving the equation 4 multiplied by 2 minus 3b is equal to 2. To start, we need to remove this bracket, and we can do that by expanding. So we can start by multiplying 4 by 2, which gives us 8, and then multiplying 4 by minus 3b, which gives us minus 12b, and this is still equal to 2. Now on the left-hand side, we'd now like to remove the 8, and this is a positive 8. So to remove it, we use its inverse, which is minus 8, and do exactly the same on the right-hand side. Now on the left, the plus 8 and the minus 8 cancel out to just leave us with minus 12b, and on the right, 2 minus 8 is minus 6. Now going back to the left, we'd like to remove the minus 12, and this minus 12 is multiplying the b. So to get rid of it, we use its inverse, which is to divide by minus 12, and we do exactly the same on the right-hand side. Now the times minus 12 and the divide by minus 12 on the left cancel out to just leave us with b, and on the right we have minus 6 divided by minus 12, which if we simplify gives us b is equal to a half. And that's our final answer to problem 1. In problem 2, we're solving the equation 5 minus 3z is equal to 8z plus 71. Now to start, we have z's on both sides of the equation, so it makes it easier if we keep our z's on the side on which we start with the most. So that's the right hand side. So we're going to keep our 8z where it is, and we're going to get rid of the minus 3z from the other side. And we do this by using its inverse, which is plus 3z. And we'll do the same to the right. So on the left, the minus 3z and the plus 3z cancel out to just leave us with 5. And on the right, 8z plus 3z gives us 11z, and we still have a plus 71. Staying on the right hand side, we need to remove the plus 71. So we use its inverse, which is minus 71, and do the same to the left. 5 minus 71 is minus 66. And on the right, the plus 71 and the minus 71 cancel out, so we're just left with 11z. Finally, to remove the times 11 in front of that z, we divide by 11, and we do exactly the same on the left. And the times 11 and the divide by 11 on the right cancel out to just leave us with z. And on the left, minus 66 divided by 11 gives us minus 6. So our final answer for problem 2 is minus 6 equals z, or z equals minus 6. In problem 3, we're solving the equation 5 plus 2u is equal to minus 1 minus 4u over 7. Now to start, and looking at the right hand side, we'd like to remove the 7 from the bottom of the fraction. And this 7 is dividing the minus 1 minus 4u. So to undo a divide by 7, we use its inverse, which is to times by 7. And we need to be careful here because when we multiply an equation, we have to multiply everything. So this means that we need to multiply the 2u by 7, and we also need to multiply the 5 by 7. So starting on the left, 5 times 7 is 35. 2u times 7 is 14u, so we have plus 14u, and on the right, the times 7 and the divide by 7 cancel out to just leave us with minus 1 minus 4u. We now have an equation where we have u's on both sides, and to make this as easy as possible, we want to keep the u's on the side on which we start with the most, and that's the left-hand side where we have 14u's. So we're going to keep the 14u's there, which means we need to remove the minus 4u from the right, and we can use its inverse, which is plus 4u, and do the same on the left. So starting on the left, we have 35, and then 14u plus 4u is 18u, so we have plus 18u is equal to minus 1, and the minus 4u and the plus 4u cancel out. Going back to the left now, we want to remove this 35, and this is a positive 35. So we use its inverse, which is minus 35, and do exactly the same on the right hand side. Now on the left, the plus 35 and the minus 35 cancel out to give us 18u, and on the right, minus 1 minus 35 is minus 36. Finally, to remove the times 18 in front of the u, we use its inverse, which is to divide by 18, and do the same on the right. And the times 18 and the divide by 18 on the left cancel out to leave us with u. And on the right, minus 36 divided by 18 gives us minus 2. So u equals minus 2 is our final answer to problem 3. In problem 4, we're solving the equation 5 multiplied by j minus 3 is equal to 2 multiplied by 4j plus 1. To start, since we have brackets on both sides of the equation, we can begin by multiplying these out or expanding them. So on the left, we can do 5 times j, which is 5j, and then 5 times minus 3 gives us minus 15. On the right, 2 times 4j is 8j, and 2 times 1 gives us positive 2. Now in this equation we have unknowns on both sides, so it's easiest to keep the unknowns on the side where we start with the most. And in this case, that's the right hand side where we have 8j's. So we want to leave the 8j's on the right and remove the 5j's on the left. And we can do this by subtracting 5j from the left and also subtracting 5j from the right. So on the left, the 5j and the minus 5j cancel out to just leave us with minus 15. And on the right, 8j minus 5j is 3j, and we still have a plus 2 on that side. Going back to the right now, we can see that we have a plus 2 that we want to remove. So we can minus 2 from the right and also minus 2 from the left. Now the left becomes minus 15 minus 2, which is minus 17. And on the right, the plus 2 and the minus 2 cancel out to just leave us with 3j. Finally, to remove the times 3 in front of the j, we use its inverse, which is to divide by 3. We do exactly the same on the left. And on the left, minus 17 divided by 3 can just be written as minus 17 over 3. On the right, the times 3 and divide by 3 cancel out to just leave us with j. So j equals minus 17 over 3 is our final answer to problem 4.